So now let's turn to validating the assumptions that we made, the LINE, linear, independent, normal, and equal variance. And like what we did in chapter 12, we're going to rely on residual analysis of the residuals to validate the assumptions. So here in a model that has two independent variables, you can think of the error term as the distance between the actual y value and the y value predicted by the regression equation. So y minus y hat, and then we can plot these residuals against the predicted y hat or individually with each x variable, and we can plot it over time if it is a time series to see whether there is any pattern over time. If it is not a time series, then it's not that critical. And then for normality, we can look at the QQ plot from StatCrunch, or you can look at histogram of the residuals and also do a box plot of the residuals. Okay, now let's go to Excel and we'll generate the residual plots and then examine them. So first thing, let's go and run the regression again, and we'll request the necessary data, residual data. So data analysis, regression, okay, the same y range and same x range of two columns. Now here let's change the output to that cell. Okay, and then we will request residuals and residual plots. Okay, and we will look at normal plot and histogram and box plot in using StatCrunch from MyStatLab. So here we have the output. Now the output generates plots. Let's look at where the plots are here. So we have one plot for price, the first x variable, promotion, that's the second x variable. So let's move these plots to where we want to put them. So we have the two residual plots for the independent variables, except one, and one for except two, price and promotion. Now we can combine the price and promotion into one, and that would be your y hat. So we can do a scatter plot between the predicted value of y hat being on the x-axis, and residuals on the y-axis. So then, since the y-axis values are in the second column, we can highlight both of these columns and insert a scatter plot. So that would be okay. Now let's move the plot. Now the x-axis for this plot is predicted y, and the y-axis is residuals. Okay. So now we need some more plots, and we can use StatCrunch for that. So let's copy the residuals. Okay, don't include the label, just the numbers. Okay, then we'll head on over to StatCrunch. Okay, StatCrunch. We're going to copy paste the data, and therefore we'll select that one and type or paste data into blank data table. Copy that, paste that, and then let's name this residual. Okay, residuals, and then we graph. We can do a histogram. Okay, so it looks kind of symmetric for normal distribution. So we'll do a box plot. Now, box plot also seems reasonable. Okay, you don't see significant skews. It's a slight skew to the left, but that's not a big problem. QQ plot. Then again, once again, QQ plot also seems reasonable. The points fall along the line, even though there is a little bit of deviation, but it's not significant. So let's copy paste these three plots into Excel. Okay. So based on and if we examine the residual plots, they all seem to be kind of random, and the variance also, the band of variance remains about the same. So all the assumptions seem to be validated here. Again, if you see the residuals against predicted y, you see that there is a pretty random pattern. So our conclusions will be, so first assumption, linearity. So plots are random, so linear model assumption is reasonable. So since the plots of residuals are random, the residuals may be assumed to be independent. So the points of the normal plot are somewhat along the line, and the histogram is not skewed. The box plot doesn't show any significant skew, so normal distribution is definitely reasonable. And the band of variance of the residuals remain about the same, so equality of variance is also a reasonable assumption. So with this analysis of residuals, we can conclude that the four assumptions that we had to make in order to do the hypothesis testing, the overall significance and the individual significances and the confidence intervals, so those assumptions, we can conclude that those assumptions are validated.